Beyond our galaxy lie countless stars, yet one stands out among them. The first ever close-up image of a star outside our galaxy has revealed a red giant that is 2,000 times larger than our Sun. This celestial behemoth is revolutionizing our understanding of the cosmos. Located approximately 160,000 light-years away, this red giant has been discovered by astronomers, who fittingly named it Behemoth. Red giants are stars in the final stages of their life cycles, a phenomenon not uncommon in the universe. However, WG64 is unlike any other. This extraordinary red giant resides in the Large Magellanic Cloud, a neighboring galaxy that has accompanied the Milky Way for billions of years. Containing around 30 billion stars, this irregularly shaped galaxy is thought to have formed due to interactions with either the Milky Way or the Small Magellanic Cloud, altering its original structure. Some scientists even speculate that in a few billion years, the Magellanic Cloud may merge with the Milky Way, triggering new star-forming regions. This event, combined with the anticipated merger with the Andromeda Galaxy, could result in a mesmerizing cosmic dance of three merging galaxies. However, WG64 will likely not exist by then, as it is expected to explode within the next few thousand to 100,000 years. A sensational image thanks to new technology. What makes a red giant a true behemoth? Is it its colossal size, the violent inferno raging on its surface, or the difficulty scientists face in studying it? The term behemoth is derived from the Book of Job in the Bible, where it describes gigantic, fearsome creatures symbolizing divine creation. WG64's sheer size and the explosive force it will unleash make it one of the most intriguing stars ever studied. As it has expanded into a red giant, WG64 has likely consumed any planets that once orbited nearby. This dramatic transformation is nothing short of an epic, almost biblical cosmic event. Scientists estimate that in about 4.5 billion years, our Sun will undergo a similar process, expanding and eventually engulfing the inner planets of our solar system. Fortunately, that moment is far in the future, allowing us to safely observe such phenomena from a distance. Although WG64 has been known to astronomers for some time, capturing a close-up of its surface was previously impossible. However, thanks to the development of a revolutionary new instrument, gravity, this has changed. Installed at the European Southern Observatory's Very Large Telescope Interferometer, VLTI, in Chile, gravity is one of the most advanced astronomical tools in existence. It combines the power of up to 4 8.2-meter telescopes and 4 smaller auxiliary telescopes to create a single virtual telescope with an effective diameter of up to 200 meters. This technology provides unprecedented resolution and precision, enabling astronomers to observe celestial objects in extraordinary detail. Surprising insights from the close-up. What can scientists learn from a close-up of a giant star 160,000 light-years away? Quite a lot. Each speck of light captured in the image is meticulously analyzed using specialized spectrometers and computer programs. By breaking down these light traces, researchers can uncover incredible details about the star's structure, composition, and evolution. Long-term observations have revealed that WG64's brightness has dimmed over the past decade. With gravity, researchers can now examine the reasons behind this change and monitor real-time developments. WG64 is already in an advanced stage of its life cycle, and any significant shifts in its structure could signal its impending supernova. Unlike Betelgeuse, a red supergiant in our own galaxy, WG64 has already begun shedding its outer layers. The star is slowly disintegrating, and the egg-shaped ring seen in its images consists of ejected material. Scientists are particularly fascinated by this structure, as no current computer models can fully explain its unusual shape. The forces at play around WG64 remain an ongoing mystery. Because the star's brightness is waning, astronomers fear that future close-up observations may soon become impossible. To prevent losing this opportunity, researchers are upgrading their instruments in the Atacama Desert to capture as much data as possible before WG64 fades from view. Observing a star so close to the brink of explosion is invaluable to science, and no expense or effort is being spared to study it in detail. WG64 may provide an unprecedented chance to witness a supernova unfold in real time. The Large Magellanic Cloud. A cosmic jewel G64 resides within the Large Magellanic Cloud LMC, a remarkable neighboring galaxy located in the constellation Dorado, or Swordfish. This galaxy, visible to the naked eye from Earth as a small misty patch in the southern night sky, was named after the Portuguese explorer Ferdinand Magellan, who documented it during his 1519 voyage around the world. At the time, early astronomers had no idea that they were observing not just stars, but entire galaxies. The LMC is a satellite galaxy of the Milky Way, situated about 160,000 light-years away. Its irregular shape suggests that it is in the process of evolving into an elliptical bar-spiral galaxy. However, it remains much smaller than the Milky Way, spanning only about 14,000 light-years in diameter compared to the Milky Way's 100,000 light-year span. One of the most striking features of the LMC is the Tarantula Nebula, a highly active star-forming region visible to the naked eye. It contains young star clusters, including R136, which houses some of the most massive stars in the universe. Among them, R136A1 is a blue hypergiant, with an estimated mass of about 200 times that of the Sun and a luminosity 8 million times greater. A true behemoth in its own right, R136A1 is at the beginning of its life, while WG64 is nearing its dramatic end. When WG64 ultimately explodes, it will release its material into space, contributing to the formation of new stars within regions like the Tarantula Nebula. Such an event would be an extraordinary opportunity for astronomers. The LMC has previously provided a glimpse of such a phenomenon. In 1987, scientists observed supernova SN 1987A, the first supernova visible to the naked eye in modern history. For researchers, this was the first real chance to study a stellar explosion in detail. Betelgeuse, another supernova on the horizon. When discussing red giants and supernovae, Betelgeuse is a key player. As the most famous star in the Orion constellation, it is also expected to explode one day. However, unlike WG64, Betelgeuse has not yet begun shedding its outer layers, suggesting that its final explosion is still some time away. In 2019, Betelgeuse experienced a significant dimming event, sparking speculation that its end was near. Scientists later determined that this dimming was due to a massive ejection of material that temporarily obscured the star's light. While Betelgeuse has since returned to its normal brightness, astronomers continue to monitor it closely for any signs of an impending explosion. Red supergiants like Betelgeuse contain vast amounts of swirling material, creating powerful convection currents that occasionally eject matter. Such events can cause temporary dimming, as was likely the case in 2019. Though Betelgeuse's explosion could theoretically happen at any moment, there is no definitive timeline. Much like WG64, it remains under constant observation as scientists attempt to understand the final stages of massive stars. By studying these cosmic giants, we are unlocking the secrets of the universe, one dying star at a time. Subscribe now. New videos are coming soon.